Hello everybody. Today's we comes to the lab tutorial session 10 for the programming fundamentals and application course. And I am teaching assistant Yang Tao for this week's lab. And in the today's lab, we are going to learn something about the NumPy library in the Python, which is a very commonly used uh, tools when you're doing something like scientific computing, and it actually significantly facilitates the operation like the matrix multiplication or something. So we are going to illustrate with some specific questions. And there are several very actually commonly used features about the basic data type, which is the n-dimensional array in the NumPy library. So for the first question, let's imagine here we got actually the first question assume that Doraemon has a list of gadgets represented by their power lines. We're going to create a NumPy array to store these power lines and perform the following tasks. Firstly, um, initialize the NumPy array with the following power levels from 10 to 50. Secondly, access and print the power line of the third gadget. Thirdly, increase the power lines of all gadgets by 5 using broadcasting and print the updated power lines. Finally, we're going to find out and print the average power level of all the gadgets. So actually, this question includes um, several features of the array data type in the NumPy library. And we're firstly going to initialize it, and secondly, index it. Thirdly, broadcasting it by using a element-wise sum operation. Finally, we're going to find out the average level by using a main function also in the NumPy library. So here's the example codes. So firstly, we import this library explicitly. So and the very commonly used name for using NumPy is that we import it as NP. So firstly, we use the NP NumPy point array, which is the like an initialization of the of an n-dimensional array in the NumPy library, and the very common used initialization scheme is to use a list data type to initialize a one-dimensional vector because um, their attributes are just similar. So in this case, we're using like a list of 5 elements from 10 to 50 to initialize the one-dimensional NumPy vector. And secondly, we are going to access the third gadget. So as it actually this array is initialized with a one-dimensional list, it could be accessed with a similar method as well. So we use the we use an integer with the square brackets to actually index the third element with the integer 2 because it's from 0, 1, 2. So we got third gadget by this way. And thirdly, we're going to explore the broadcasting method because while you're doing something like uh, multiplication, you're divided the array by something, or is add by something, or subscribe by something. So when you're using this like um, using add, subscribe, multiplication, and divide. So this basic operation are also applicable to the n-dimensional array in the NumPy library as well, but actually defaultly could be interpreted as an element-wise operation. Um, so what do I mean by element-wise? Element-wise is it means that your every operation would be like broadcasted to every single element. So where you're at add this array by 5, you mean that you add every single element by 5. And finally, um, the average number of the gadget could be like we could also like use a for iteration to for every single element in in the power lines. We use a some variable to add it e, and finally finally divided by the length, right? But this is actually like it has been implemented as a as an inner function in the NumPy library, so it's very convenient. We could just use the NumPy point mean function to calculate the mean of the um, of a given NumPy ND array. So we just use the function, or we could use it this way. This is also like implemented as a like a class method of the ND array data type. So this both of that is they are equivalent. Both of this way is equivalent. So let's run it. And we got the result of that. Like the third gadget is of course 30, and um, after add every element by 5, we got this new power lines, which is the updated power line. And finally, we could actually got average power level by simply using the function of NumPy or the class method of the ND array, and the average power level is actually 30 as well. So that's the first question. Question 2. Let's consider a little bit more complicated question where it is the two-dimensional cases. And for this question, let's assume that Doraemon and his friends go to a field trip, and their scores for different activities like flying, running, and swimming are recorded in a two-dimensional NumPy array. So actually, we got two dimensions here. Well, the first is the different person like Doraemon and his friends. And secondly, the second dimension is the different activities uh, from flying to swimming. So at this time, the data is actually a matrix. So it's different from the vector we learned in the first question. And our task is to, like, firstly, the same, initialize a two-dimensional NumPy array. And secondly, we also are going to explore the index of the two-dimensional array. And thirdly, which is also the same, but this time we're going to calculate the average score for each activity, which means it is column-wise, and we print the results. Finally, we're going to explore the reshape function because like for two-dimensional arrays, it could be represented as a one-dimensional vector as well if you actually flatten it. So it's actually another attribute, another feature of the like high-dimensional array data type. So we're going to illustrate that also with the with online GDB. So while we are going to um, handle in this case, we're like firstly we have to import the NumPy library first, and following we going to initialize that. But this time the initialize function is just the same because we are always like using a NumPy point array to initialize a array when uh, no matter we're initialize a vector or a matrix or even high dimensional tensor, we're going to use this function all the time. But the problem is that we have to use a like a user nested list, which is actually itself is a two-dimensional list, and every single element of the list is actually also a list of a three element. So we got three lists like that, and it forms actually together they form a 3 times 3 matrix. So this is the initialization of the two-dimensional NumPy array. And secondly, we are going to access and print the scores of the firstly second friend, and besides we're going to index the swimming, which is the last activity. So actually, we got two index here. The first is that we're going to find the second friend. Second friend is could be indexed by 1 because it's from 0 to 1. So 1 is the second friend. And the second index is that the last activity. So we could access that by whether like we from 0 to 1, from 0 to 2, like three activity um, um, three activity in total. So we use 2 or we use -1 to find the last to find the last activity. So here I could use -1. So by this way we found the scores of the second friend for the swimming. Um, so while you're doing this, like we're like index a two-dimensional matrix by two index. And so by this way, we could access the scalar of the specific location, which is actually, let me find it, the second friend, which is the second row, and the last activity is the last column, which we assume like we could imagine that it's actually 91. So later we'll see the result. And another thing is that if you actually print something like this, so we initialize another variable, we could also a different way of using the index two-dimensional index is like this. You could also use this by like replacing the 1 comma -1 with two like two independent index. This could also work as well. Um, and for the like the third question is to calculate every score of each activity. And this different from the first example because at this time we are going to um, like we calculate every score for each activity, and the result of that is also a vector because we still have different person, right? So we're going to like doing this by calculating the first column, and we output an average number, and we then calculate the second column, and we output an average number, and then it's a third column. So the actually the output is a 1 times 3 vector as well. Uh, so it actually at this time we're not going to use a simple like NumPy point main function, but we use this. We use a comma, then we explicitly state there that x equals 0 because we are going to like to calculate the average score for um uh maybe I mentioned wrongly before, but um, it's like the same. We are going to calculate the um, like calculate the average number for each row. For each row, then we got actually we got a column-wise vector. So by explicitly state there that the actual axis equals 0, we calculated the average number for only for 0 dimension, which is the for different person, right? So we output the average score, which is actually still a vector. And finally, we're going to reshape the array to to have only one column, but has many rows as needed. So it actually just like we flatten that to a row vector. Uh, uh, we actually flatten that to a column vector, which has only one column and maybe 9 rows. So we just use this reshape function. And we mentioned that for the first dimension, which is the row dimension, we could have as many as we needed. So we actually implement this by using a -1 at the 0 dimension, which means that it could be whatever it needed. Could be whatever it needed. But it actually you could use one. You could only use the -1 once in the reshape, because if you use like 2 minus 1, like use it twice, and it actually cannot interpret it cannot inference the output dimension, right? Because you have two dimension that you are um, that are actually unknown. So it's gonna be impossible for the um, NumPy to infer that. So we could use we could use the -1 only once in the reshape function. And for the column, we use a 1 to represent that we wish that we expect that we only have one column, so we state that like explicitly. So when we are when we output that, we found that like it output that the second French women score is just like we expected. It's 91, and these two method of usage is just the same. And for the average score, it's actually for different activity. So there's the average score of different person for the first activity and the second activity and the third activity. And finally, we got the reshape scores array. We could tell that this is actually a we could describe that as a two-dimensional array. It has actually 9 rows in total and 1 columns in total. Um, so if you print out the shape of that is actually uh, 9,1 shape. So that's the so so in this case, this is equal to you reshape that as the um reshape that as uh, uh the number of elements, which equals 3 times 3. So that's the um this is equal to explicitly stated explicitly stated as 9. Um, so this two is equal. So that's the question 2. The question 3 of this lab is actually to handle the 3-dimensional cases. And it says that the Doraemon has 3 different type of gadgets, and each type have power levels across multiple dimensions. Which is like illustrated below. You got like three different type of gadgets, and each type have like um, different different kind of specific gadgets, and each gadget uh, has a power levels which is not a scalar at this time. And actually, the power levels itself is also a vector. So we got a sort of three-dimensional data type. And the first thing is to initialize a three-dimensional NumPy array and to store this sort of values. And secondly, we're going to use the index operation as well to access and print out the power level of the first gadget in the second type. And thirdly, we are going to do some sort of matrix multiplication to convert the given power levels of different gadgets into the required compatibility ratings. So the example code is like this. First of that is to like import the NumPy library, and secondly, we could initialize a three-dimensional array, like mentioned before. All of that, whether it's of n-dimensional array, no matter it's of what kind of dimension, it could be initialized with the NumPy array method. It's actually a class initialization method of the uh, n-dimensional array data type, and it actually receives something like a list or tuple. And in this specific case, we got a sort of like three-dimensional nested list, and like there are composed of three different two-dimensional lists, and that's the input data. And after initialization, we could do these like the index operation by by combining different index using the comma. And this is could also be like implemented, like I said before, using using three independent index. This two way of implementation is equivalent. And besides, um, we are asked to use to find out the like the first gadget in the second type. So we 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 have known that the first, like the outer dimension, is for the different type, because we got three different types. So the outer dimension is three. So we use one to access the second type, because it's from 0 to 1. So 1 is means the second type. So that's the second type, and this is the first gadget in the second type. And this is I don't know, it's maybe like the zero dimension of the power level. Maybe there are actually two types of different power levels, and we're going to access the first power levels of it. So this two implementation is equivalent. And finally, we're going to do the matrix multiplication. And the matrix multiplication could very easily be implemented in the NumPy library by using the makeMul function. Actually, it does mean the matrix multiplication, right? Multiplication, something like that. It's spelled like makeMul, and the this function take two different parameters, two parameter as input, and both of them are actually ND array. And but there's actually an implicitly mentioned requirement for the input parameter shape, because just like what you have learned in the linear algebra, um, when the um, when the last dimension in the um, last dimension in the first array that actually equals the first dimension in the last array. C, F, G, something like that. It uh, outputs an array with the shape A, B, F, G. So C must equal C. The last dimension in the first parameter equals the um, first dimension in the latter parameter. Um, and it actually couldn't be switched. So if you are like switch these two parameters, um, it actually would would be an error. So remember to keep the shape um, consistent. So if you are calling this function like this, uh, it will be an error. So let me change it back. This is the correct version. And also, while you're using NumPy or PyTorch like this, you could also use the at using the at this indicator as a to actually um, implement the uh, matrix multiplication. The at is the same as this, but remember this is actually couldn't be switched. The order of these two parameters is fixed. So we could print out to check whether this like different sort of different kind of implementation could output the same answer. So we could see that the like the power level of the first gadget in the second type, which is the second type, there are three types. So we got this one, and we access the first gadget, which is this, and the power levels as a vector. We are going to find out the first one is 50. So the answer is correct, right? And the two types of implementation actually output the same answer. And this is also the third part is also the same. But we could once again to check the output shape is because um, the output shape in the input and output shape in the matrix multiplication is very important. So we could also like to print the shape of the input and output shape, input shape to debug. And we can see that the input shape, not this one, shape, one shape. We could see that, like I mentioned before, the last dimension in the first parameter of the mate mode should equals the like the first dimension in the later parameter. So 2 equals 2. So the output the output shape is 3, 2, then 2 is from uh, the second matrix. And the output shape is like that. So the answer is correct. And here comes to our last question, which is an n-dimensional case. And let's say that the Doraemon's time machine stores time travel experience in an n-dimensional array, and each experience have a time, location, and duration. And actually, for this specific case, we got a three-dimensional array actually, but all of the operation includes in the following tasks could be easily extended to even higher dimensional cases. So call we could also call this case as an n-dimensional case as well. So like the first task is to create a three-dimensional NumPy array which stores all of the experience information into a 2 times 3 times 3 shaped three-dimensional array, representing 2 time travel experience, and each is with 3 attributes, including time, location, duration, and fill it with the random integers between 1 to 100. And we could achieve that by using the NumPy point array point randint, which represent the random integer in the by using the NumPy library. And secondly, we are asked to transpose the array to switch the shape. And thirdly, is to find maximum duration, and the duration is of course the last dimension. So we're going to do the maximum operation in the last dimension. And finally, we're going to use a slicing operation to extract the data for the first experience. That's exclude the second experience. So that's the just like what we do before in the all the former cases, we're using the index function we're using the index operation to get a specific element or specific row or column of the array. It's just the same. So let's see the example codes. The first is about to create a three-dimensional array using the NumPy randint function. And we state that the range is from 1 to 101, and size is 2 times 3 times 3. The only thing you have to remember is that there's a difference between the randint function and in the NumPy random library and in the original random library in the Python. So the difference is that we're using the NumPy. The randint actually includes A but not includes B. And while using the randint in the original random library, it includes both A and B. So that's the difference. So while you're using the random randint, you're going to write 1, 100 to represent the equivalent way. And secondly, we transpose the array to switch its shape and to print it out. And this is achieved by using the transpose function in the NumPy array in the NumPy library to receive an array and to switch the shape, which is actually to make the column to be the row and make the row to be the column, and it could be extended to higher dimension. And the actual meaning of that is to switch to change the order of the dimensions, make the inner dimension to be outer and make the outer dimension to be inner. This could also be achieved by using a point T, which represent it is actually also linked with a maybe a class method of the NumPy array data type. So this two implementation is also equivalent. So we print both way to check. Thirdly, we're going to find the maximum duration, which is very similar to what we have done in the question 1, 2, 3, in which we're going to find the average score in some specific dimension. So in this case, we replace the NP point mean with the NP point max to find the maximum value instead of average value. And also we explicitly state there that the axis equals the last dimension. So the output of that is actually equals to 2, 3, because the last dimension is eliminated by the maximum function. And Um, this operation could also be achieved by um, using a cloud method of the ND array data type by using the experience point max, and we state that the axis equals the -1, which is also a equivalent way of implementation. And the last task is about to extract the data for the first experience. And as we know, there's only two experience stores in the three-dimensional array. And for the first experience, we just have to like to use the index for the first dimension. So we use a 0 for the first dimension to extract that. Um, but another thing is that you could also use something like this by replace the by using like using a three-dimensional index, but only explicitly uh, give the first dimension an index 0, and for the later two dimension you use a column to instead of integer, which represent that that's from the first dimension to the last dimension, maybe n, or is actually the shape of the second dimension. First experience data point shape, and that's the shape in the one dimension, which is actually um, from the first element to the last element, which represent you want actually all of the element in that specific dimension. So column actually means that. So while using a column, you means that you don't want actually to slice to exclude any element in that specific dimension. You want all of the element. So that's equivalent to just to use the index for the first dimension. So we could print the result of that to check. And we could see that the transpose experience array is actually and the order of that uh, uh, is different from the original one. Original one is 2, 3, 3, and while you transpose it, it becomes like 3, 3, 2, which is different from the original, and we could see the um, print original rate to check as well. And for the second output is a 2 times 3 array, which is corresponding to our assumption before, because the last dimension is duration and is eliminated by using the maxima function. And for the last case, the output data is actually the first experience related data, and we could see that these two different kind of implementation output the same, and that's the case for the question 4, which we're illustrated with three-dimensional NumPy array, but it could be actually extended to higher dimension as well. So that's the all of the question 1 to 4 in the lab 10, which is about the how to use the NumPy array in the NumPy library to do some scientific computation, and especially some matrix or tensor manipulation. And I hope you could got a overall picture of this NumPy library while you are doing something related to linear algebra or machine learning. You could actually benefit a lot from this library because it actually the matrix multiplication or broadcasting could be implemented in a very uh, convenient and efficient way in the hardware level because it's actually implemented in a parallel way. And while you're using a for iteration to do maybe this equivalent to achieve the equivalent function using the for iteration, it would be much more slower than the NumPy implementation. So where you're doing something um, like matrix multiplication, just try to use the inner function in the NumPy library to improve your efficiency. So that's all of the live today.